Hello everybody, I just want to talk about the mass spectrometry this time. And this is not a lecture video, this is more like a documentary kind of thing. Uh, Even though I'm going to tell some facts and information about it, um, definitely it's not a lecture. I'm just going to tell what smart spectrometry is. Instead of teaching you the principles and all, I'm just going to teach you just going to tell you what I do, what's the idea behind it. Like, what's the yeah? Let's start with what's the idea behind the mass spectroscopy. Uh, we take mass spectrum of compounds. Generally, the idea is to know what is the spectrum a compound is giving, so that we can match the spectrum with an already existing library of spectrums. It was taken usually by people if they buy a chemical compound, they want to make sure whether it's exactly the same compound what they are expected to get. So what they do is they will take a mass spectrum. How they take a mass spectrum is, see, before putting anything inside the mass spectrometer, we have to make sure it is pure. Otherwise, the whole spectrum is going to be not good. For example, we are not going to take a mass spectrum for a mixture unless we separate the two compounds, unless we separate the compounds present in the mixture. I think you got the idea. We are not going to take a mass spectrum of a mixture. We only take a mass spectrum for a single pure compound. Then only we can able to match that spectrum with the already known existing library. Then we can get into some conclusion. So what if you have to take the mass spectrum of a mixture, if you want to take a mass spectrum of a mixture, you should separate it. And the well-known separation what people use is chromatography. For example, let's assume that you have a reaction mixture, and what the compounds you are expecting and what's your starting materials are all volatile. Then what we are going to do is a gas chromatography. What I'm gonna do is, if you have a reaction mixture and you're giving it to me, by extracting the reaction mixture, whether you got a solid product means you're going to dissolve it and give me, or you just have a reaction mixture, you want to know what are the things present in it, you're going to extract and give it to me, or give it to any mass spectroscopist. And what he's gonna do is he's going to inject it into a gas chromatography, uh, which is having a mass spectrometer as a detector. Um, it means we call it GCMS. It means the GC comes with an MS. A GC can only separate the mixture, but it can't. But to know whether the separation has happened or not, we need a detector, and so we use a mass spectrometer as a detector for the GC. How the separation takes place, or what the principle behind GC and MS. There are many good lectures in YouTube. You can see it, but I'm just giving you an idea like what's gonna happen, why we need to do GCMS, so that we can what's the just an idea behind it. So we have a GC which separates the compounds of the mixture. The mixture goes to a column, and based on the affinity with the column, it's going to separate, and different compounds in the mixture will come out at different times. Therefore, we have an y-axis of time and an x-axis of an intensity. So a detector is a mass spectrometer. So slowly the compound will come out of the column. In GC we use columns to separate of the column, and MS is going to detect it, and we get peaks at different time frame. Like we have a time domain, we have a time axis and the intensity axis, and we are going to get peaks in the GC chromatogram. Like it's the chromatogram, and what peaks the mass spectrum related to the peak is given by the mass spectrometer. Like what are the ions present in the particular peak, Like peak is a quantitative reflection of a compound. It means when we have a peak, it means there are ions coming at that particular time, that some ions is eluting out, and the mass spectrum of a particular peak we're gonna get, and that spectrum we are going to match it with an already existing library. Then we will know what is in that peak, by means we know what is in that mixture. That's what the idea of it. And that's what we are going to make. We already have a spectrum only for pure compound. We are going to purify, not purify, we are going to separate the individual compounds using the column, and we are going to find the spectrum of the individual peaks and then we match it with the library, and then we will get what individual peak is. That's how we take the mass spectrum. Even if you want to make the spectrum of a pure compound, you still put it in the GC and then you elute it out and you get a single peak. If you have a mixture, the chromatogram will have a number of peaks, and if you have a single compound, you are going to still going to do it in the chromatogram and you get a single peak. And I didn't see there is any way to take a mass spectrum without a chromatography thing attached to it. I don't think how we're going to make because we need ions, and what we're gonna do, I think there are ways to take mass spectrum without the use of chromatography for pure compounds, but I didn't seen it. But generally the mass spectrum is taken with the chromatographic setup which will be present before the mass spectrometry, and this is for GC. If you have a compound which is not volatile, we use LC as the thing to separate the mixture, and we will have a mass spectrometer attached to the LC, and the same thing is there, but there's a problem with the LC part because gas chromatography is only with the gas chromatography we can match the spectrum. There is no library available for the LCMS spectrum. That's where the problem comes. If you take an LCMS spectrum, you have to match the base peak. You should already have some knowledge about what's gonna come. But in GC, there is already have a library of spectrum. Why this problem comes in GC, there is only one kind of ionization thing. I think I'm going a little deep now, but for the time being we live with that. There is no library available for LCMS. There is only library available for GCMS. Why? Because it happened because of the difference in the ionization procedure present in the different mass spectrometers, which comes with the GC and which comes with the LC. In LC, the ions produced in a total different way for the mass spectrum, and in GC, the ions produced are in some other different way. Therefore, we only have libraries for GC. If you give for LC, you still get the peak, you still get the spectrum, but we are not going to match it with the library. I mean, because the conditions because there's lots of things in it. I will tell in a later video why it's not like that. For the time being, I think you can understand what we're going to do if you have to take a mass spectrum. First you have to separate and then you have to take the spectrum, and that's what it is.